Through yesterday, you should have completed Module 2. Should be done with Module 2 now. That was testing due last night about midnight. So I see that several of you have got the test in, but there's a few of you that have not yet turned in either parts 1 and 2 or just parts 2. And there's a couple people that are behind a little bit farther than that, and they still need to get caught up on some other items. So there are a few folks that are a bit behind on getting things caught up. So you can do it this week. Today is our only class. We will not have class Wednesday or Friday or any other days, because Wednesday, Thursday, and Friday, there's no meets, period. No meets for any class, because you guys get a break and we're going to be in teachers' meetings. We'll be in teachers meetings, so you guys do not have to attend any meets Wednesday, Thursday, and Friday. So for those of you that are behind, what a great opportunity for you to get caught up, because you're not going to have to be going to any classes, not going to be sitting in any meets anywhere Wednesday, Thursday, Friday. So great opportunity for you jumping there. For those of you who are caught up, and if you got this week's stuff done by tomorrow, then you'll just have a 5-day weekend. All right, so get your stuff done and have a 5-day weekend. I encourage that. But yeah, no meets at all Wednesday, Thursday, Friday. So this will be our only time that we will meet as a class this week at all. So, okay, that being said, let's look at what we are reviewing. So we're starting the third module, and we're starting with greatest common factors and special products lesson. I will tell you, if there's anything that is important to learn in algebra class, it's being able to factor. That will be used in all your math classes. You've done it some up till now. You'll be doing it a lot more in the future. Make sure that you know how to factor. So pay extra attention to these two lessons. There are several videos in here. Don't short yourself. Watch all the videos. There's some right here on page 1 of this lesson. Here's a 2-minute and 17-second video. There are 4 examples on the first page alone, 4 examples. The first one's a video, and the others are ones where you're supposed to check your work as you go. So when you're doing that, like example 3, it'll say factor this completely, gives you this polynomial. So first you create a list or a factor tree. So it's hidden because you're supposed to have some paper and pencil and do that yourself, and then click on the list and see if your list matches their list. All right, that's how you use these lessons. That's how you make sure you know what in the world they're talking about, is if you can do it on paper and then check to see, did I get everything? Yep. Oh, I missed that one. Okay, I say, yeah, I should put that. All right, yep. And then you go and it has you make the factor tree. And then it says, now find the greatest common factor among the variables. And that's hidden too. So you do that, and then you click on the next button, and it'll tell you what they are. You go, oh, yep, I had those. Perfect, I got it right. So that's what you're doing on these. Every lesson you should be doing that. You should have pencil and paper. And as it puts it up there and gives you an example, you work through it on paper and then click to check what they did and see if it works the same. That's how you learn algebra, is you do algebra. All right, so let's look at what this talks about with factoring this week. Let me put up my camera. I'll have the camera launched here even. Okay, put it up on the screen. Fabulous, it's coming. All right, so let's talk about greatest common factors, special products, and let's use some of the examples they give right here in our lesson. So they have right here on page one of the examples is to factor 6a to the third. I'll try to write this really big where you can see it well. Plus 9. So they got a to the 6th, b to the third, plus 20, a to the 5th, b squared. So we got 6a to the third, b to the fourth, plus 9, a to the 6th, b to the third, plus 20, a to the 5th, b squared. And they want to know the greatest common factor. So when doing that, you have to look at each piece. Like first you look at the coefficients, the 6, the 9, and the 20. And do they have a greatest common factor? Is there any number that we can divide out of all three of those evenly? Right? We know with 6, you could factor out 2 or 3 or 1 or 6. That's the only ones, right? 2 and 3. But we can't take a 2 out of 9. We can take a 3, so those are in common, but 6 doesn't come out. So 3 is the only thing those have in common. But when we get over to 20, 20 is not divisible by 3. That doesn't work evenly. So these are already as simplified as it can get. We cannot factor anything out of that. So let's move on to the next thing. Let's look at the first variable, the a. This has an a to the third, that has an a to the 6th, that has an a 5th. So a to the third means this is an a times an a times an a. This is an a times a times a times a times a times a. And this last one is 5 of them. A times a times a times a times a. So when we look at what they have in common, well, this one has a to the third, this one has a to the third, and this one has a to the third. So we can factor out an a to the third power out of all three terms. Right? So this one, there's no a's left. This one, we still have 3 of them being multiplied times each other. So we still have an a to the third left. This one, we've taken out 3. There's still an a squared left. So the first term has no a's when we factor that out. The second one is still going to have a to the third. Third is going to have a squared. So let's check one more thing. Let's check the b's. B to the fourth, b to the third, b to the second. All right, so we got B, 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 B. Over here we got B, 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 and finally 2 B's on the last one. So what do they have in common? Well, they all have 2 B's being multiplied by each other. So we can pull out a B squared. Okay, so that leaves, these are gone. That leaves 2 B's. See, those are gone. These are gone, at least 1b, and those are gone. Okay, so what's left when we factor this out of all of that? Put this out there because, it's being multiplied by that since we factored it out. So in the first term, 6, we still have the 6, remember, because nothing factored out of the coefficients. A to the third, those are all gone. And b fourth, since we took b squared out of b fourth, that took 2 of the b's, we have 6 b squared is the first term. That's all that's left. Then we got plus 9. What's left with a? We got a to the 6th. We factored out a to the third, so we took 3 of them. That leaves a to the third. B to the third, we factored out a b squared. That left 1b. And then the last term, we have a plus of 20. A to the 5th. We factored out a to the third, so that leaves 2 a's being multiplied by each other and no b's. So this is the same thing as this up here, except we have factored out the greatest common factor. This is the greatest common factor that was in all of these. All of these had an a to the third and a b squared. Some of them had more than that, but they all had at least this. So this is the factors. So you need to be able to do that for sure in any situation. Go through and pull out the greatest common factor so that simplifies things. See, now we've got it simplified where this just has a b squared, this just has an a squared. Before, they all had a's and b's and everything. So this is a simpler polynomial now. All right, let's move on and look at another example in taking factors here, greatest common factors. Oh, let's look at difference of squares. Oh, that's a good thing to look at. So difference of squares. This is a shortcut in factoring if you can recognize it. Let's say we have x squared minus 25. Okay, these are both squares. So what do I mean by squares? That means both of these are a number that I can multiply something by itself and get. And it's being subtracted. The second square is being subtracted from the first square. Because with x, I can multiply x times x, and that's x squared. So that makes this is a square because it's the same as an x times an x. 25 is a square because if I took a 5 times a 5, that's 25. The difference of perfect squares. When you see the difference, and difference is a math term, it means when you subtract something, you get a difference. What's the difference between the two when you subtract? Difference of perfect squares. Sometimes I should say difference of squares. When you see that, our factors are automatically the two numbers that we need to make these squares, and one of them is positive and one of them is negative. Automatically. When you have the difference of perfect squares, we know right away that's x plus 5, x minus 5. We don't have to do a lot of work to get there. Now we can double check that. We just multiply them back together and see, did we end up back here? So we have to distribute x times x is x squared. X times negative 5 is negative 5x. Now we have to distribute the 5 to both terms. 5 times x is 5x. 5 times negative 5 is negative 25. See both of these terms? They cancel each other out. That just leaves x squared minus 25, which is where we started. So difference of perfect squares is a great shortcut. When you see that, you know instantly, oh, I can just jump straight to these are the factors because this is the difference of perfect squares. So that's very, very useful. They kind of give the property as this. If you have a squared minus b squared, so that way they can be any numbers, then you know it's a plus b times a minus b. So that's the difference of perfect squares summed up for any two squares. Any two squares. And they actually use this in some math. You could make these perfect squares. You can have 148 squared minus 131 squared. And we can calculate that just by adding those two numbers, subtracting those two numbers, and multiplying that together. A lot of times that's quicker than doing all the big stuff. So on page 2, the lesson has a little quiz where you try to figure out if something is a difference of squares or is it just an expression, and you drag and drop and let you know if you're right. So go through that on page 2 to see if you can recognize difference of perfect squares, because it does save you some time. So let's see. Here's a sample problem where we can use that, where it comes in useful. So what if they said factor this 3d to the 4th minus 363 d squared? And we look at that, it's like, man, I don't want to have to factor that. That looks like a mess. Well, we start like we did up here. Find the greatest common factor. 363 and 3. Well, we know 1 and 3 both divide into 3. So does 3 go in here? Yes, 3 does go in there. So when we do that with our calculator, well, let me go ahead and pull the d's out first. D fourth and d squared. So d squared will come out of both of them. 3 out of 3 is 1. D squared divided out of d to the 4th is just d squared. So I'll erase the 1. We don't need to write 1 as a coefficient. Minus, what is 3 divided into 363? It's 121. 3 times 121 is 363. And the d squared we factored out. So by finding the greatest common factor, 3d squared, we've simplified this to 3d squared times d squared minus 121. But if you know your multiplication tables, and that sure makes math easier, 121 is the perfect square. What multiplies by itself to be 121? Anyone know? I'll give you a chance to throw that in the chat before I expose the answer. Anyone know? 121. Oh, a lot of you guys are on that in a hurry. That is the same thing as 11 times 11. So this actually factors down to 3d squared times d plus 11, d minus 11. And that is the smallest factors we can break this down into. We pull out the greatest common factors, and then this factors nicely into d plus 11, d minus 11, because it's the difference of perfect squares. Difference of perfect squares. All right, good job with that, guys. Good job. Let's move on. Let's pull up another example here. Perfect square trinomials. Perfect square trinomials. You get those by expanding. Let's turn this over. Expanding binomials, and you get perfect square trinomials. So let's look at, for example, g minus 3 squared. This will create a perfect square trinomial because we know it's the product of two squares. It's this times itself. G minus 3 times g minus 3. Right? That's exactly the same thing being multiplied by itself. So g times g is g squared. G times negative 3, negative 3g. Now let's factor the negative 3 and let's distribute it inside the parentheses. Negative 3 times g, negative 3 times negative 3 plus 9. Like terms, this is g squared minus 6g plus 9. This is what we call this a perfect square trinomial because it's made, its factors are exactly the same. The factors are g minus 3 times g minus 3. That's the factors of this. So when you start recognizing those patterns, that 9 is 3 times 3, or negative 3 times negative 3, and negative 6 is negative 3 plus negative 3, you get to where you recognize that to be a perfect square trinomial. And it gives a real good detailed list on page 3 in the lesson. You go through it step by step by step, and it will walk you through and show you how to recognize that. I'm not going to do all of that because we've only got an hour and a half total for class. I don't want to use all of that because, you know, the mind only absorbs as much as the butt will tolerate. And so your butt will get tired of sitting there and you won't recognize anything anymore with your brain. So, but go through that lesson on page 3, step by step, and let it show you how to recognize those patterns. And then it has where you can test again. It gives little boxes and it gives you an expression and you drag it to the box. Do you think that one's a perfect square trinomial or not? And it'll tell you, yes, you're right. No, you're not right. So use those examples that help you walk through them. All right. So let's go to the next thing. All right. So page 4, let's look at that one. Okay, let's take a step farther. It says, let's look at perfect square trinomials again. So if we had t to the 8th minus 81, t to the 8th minus 81, you might not immediately recognize that as a perfect square. The 81, that's 9 times 9, but t to the 8th, yeah, absolutely. That's t to the 4th times t to the 4th. Remember when we have exponents multiplied times each other, we add them. So this is the same as t to the 4th plus 9 and t to the 4th minus 9. Right? It's the difference of squares. Difference of perfect squares tells us these are the factors of that. But if we're paying attention, and this is where you don't want to fall asleep on that, this right here is also the difference of perfect squares. Right? So this is finished. T to the 4th plus 9, that cannot be factored anymore. But this t 9 is 3 and 3. 1 plus 1 minus this. Oh, I'm sorry, t squared, because that's t to the 4th. So t squared times t squared is t to the 4th. 3 times 3 is 9. 1 positive, 1 negative. So it factors down to this. We had to take that extra step. If we're not paying attention, we'll end up not having a final simplified answer. And then we look at this and we say, well, this could be another one, except for 3 is a prime number. It's not a perfect square. So we have to stop, even though we have a minus again there. Anytime you have a minus, check to see if that's the difference of squares. And sometimes you just have to stop there. All right, let me look at our lesson summary for 3.01 and see if we missed anything. Greatest common factor. Yep, that's where we pull out, in this case, a to the third b squared. There wasn't a coefficient we could pull out, not a number. Difference of squares. Yeah, we talked about the difference of squares right there. Perfect square trinomials. That's where you get like this, where the first and last terms are perfect squares, and the middle term is twice whatever the square of this term is. Like this could be -3 times -3. So that's double the -3. There's a pattern. And then checking to make sure you can't factor further after doing the perfect squares. It has that in there too. So let's see. Let's give one more example for lesson 3. I'm sorry, for lesson 1, 3.01. Then we'll move to 3.02. Let's look at this. If we had 3w squared plus 15w plus 18. All right, so first thing we want to look, is there any greatest common factors? We always want to look at that first. W squared, W, there's no W over here. 3 and 15, 3 would go into 3, 3 would go into 15, and 3 would go into 18. So we can factor out a 3. So that'd be W squared. If we factor a 3 out of there, it would be a 5W because we divide 3. We divide 3, we just have 1. Divide 3, we just have 5. Divide 3 plus 6. All right. This can be factored further because I'm going to use the X method. When you put this little X method on top, I'm going to put this and the 6 underneath. I need it to multiply, put an asterisk, multiply to be 6 and add to be 5. So what numbers multiply to be 6? Well, let's see, 1 and 6, -1 and -6, 2 and 3, -2 and -3. Those are all numbers that can be multiplied together to be 6. So it could be any of these, but there's only one set of those numbers that add together to be a positive 5. 2 plus 3. So that means the factors are W plus 2 and W plus 3. So 2 and 3. 2 and 3 multiply to be 6. 2 and 3 add to be 5. So that's the two numbers that this will factor into. So this factored all the way to that. All right. Like I said, there's lots of examples, lots of extra stuff to help you work through and make sure you're understanding in lesson 1. So don't short yourself on that. Make sure you go to that. Let's look at 3.02. And this talks about factoring by grouping, which is a very popular way to do this because it can be very useful. So let's look at this polynomial right here. Okay, that's a quadratic equation, right? Because it's x squared. So we can use a part of the quadratic formula to figure out some truth about our answer. So, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. That's the quadratic formula, right? When we have a is the coefficient of x squared, b is the coefficient of x, c is the constant. So 1, 8, and 16 is the ABC. So for the quadratic formula, I just want to look at this part right here. I'm going to highlight this part right here. This is called the discriminant. The discriminant. Everything under that radical. This is the discriminant. And if we just look at the discriminant for this, it'll tell us a lot. So let's just break out the discriminant. The b squared minus 4ac. And let's evaluate that for this. Like we said, the A was 1, the B was 8, and the C is 16 because that's the coefficients. And let's put that in here. B squared, 8 squared minus 4 times A is 1, times C is 16. So this is 8 squared is 64 minus 4 times 1 is 4. 4 times 16 is 64. So this is 0. The discriminant underneath here is 0. If this is 0, if that's 0, means there's one rational solution. That means one rational solution. That's 1, 0. If you graph it, it would touch the x-axis one place, which means it's going to bounce off of it because this is a parabola, right? It would hit the x-axis and bounce off of it because that would be a quadratic. With this being 0, it's one rational solution. What else do we know? If this is greater than 0, means there's 2 solutions. And if it's less than 0, that means there's 2 complex solutions. Remember what a complex solution is? That would be, has an imaginary part. It might be 2 plus 3i. It'll have complex. That'd be a complex solution with imaginary part. So this discriminant, just that part underneath the radical, tells us a lot. If we just figure out from that, is it 0? Is it bigger than 0? Or is it less than 0? There's either one solution, there's 2 solutions, or there's no real solutions, but there's 2 imaginary solutions, 2 complex solutions. So a little shortcut to kind of help us know what we're looking for with a quadratic. It's only with a quadratic because this is the quadratic formula. You can only use that when you have a quadratic formula. All right, so we're going to talk about grouping by factoring here. And so the first example they give is they start, and instead of factoring, we're going to go the other direction. Let's start with a t plus 3 and t plus 11. Okay, and so we're going to multiply these together to get a polynomial. So t times t squared, t times 11, 11t, right? That's the first, that's taking this first term and multiplying it by both of those. Now we have to go and we take the 3 and we have to multiply it by both of those, 3t plus 33. Okay. Now what do we have? We have like terms right here. The 11t and the 3t are like terms, so we can combine those. T squared plus 14t plus 33. That would be the trinomial we get when we multiply those together. Okay, now let's change it up just a little bit. What if we made this t plus 3 and s? Let me make it m. M is easier to see. S looks like a 5 sometimes. M plus 11. Very similar to this, instead of having t in both of them, though, I changed it where I have a different variable. So t times m, mt. I'm putting them in alphabetical order when you have 2 different variables. Alphabetical order, mt, and then 11t, right? So then we have to take the 3 and we have to distribute that. So plus 3m and then 33. Now in this case, we don't have any like terms at all. This is a t, this is an mt, this is a t, this is m, this is a constant. There's nothing else we can do to put those together. So we have to pay attention when we do that. Why do we have different outcomes? This one is a trinomial because we can combine that. This is not, this is 4 terms, 4 separate terms, right? So this is 4 terms. So this helps us when we understand kind of how this works. that we go backwards if we're trying to factor by grouping, that sometimes we need to put four terms together and factor them. So this has an example. Let me see what example they're doing here. Fabulous. So let's look at this example where they start with four terms and we're going to go backwards and we're going to factor it out. So let's say we have c squared d minus 4cd plus 4c minus 16. Okay, when we look at that, there's not a greatest common factor. This is just a 1. There's no coefficient other than 1. And so that doesn't help over here factoring anything bigger than 1 out. There's a c squared, but this just has a c, this just has a c, and this doesn't have a c at all, so we can't factor a c out. Same with the d. We got a d and a d, but no d's here. We can't factor anything out as a greatest common factor. But with four terms like this, we can factor by grouping. And what we're going to do is we're going to look at it and say, okay, let's just look at these first two, and then I'll look at these others separately. So if I just had this, now I have something I can factor out of there, right? There's a C and a D and a C and a D in both of those. So I'm going to factor out CD. What's that leave? If I take CD out of C squared D, that leaves just the C. Because if I multiply these back together, I'm back to here. If I have minus 4CD and I factor out a CD, when I divide that by CD, that just leaves negative 4. Okay, so I factored that just out of that. Now, what can I factor out of here? I have a 4C and I have a negative 16. So the only thing that would factor out would just be a 4, because 4 would go into 4 one time and 4 would go into negative 16 negative 4 times. So if I factor out a 4 out of that is C, and 4 divided negative 16 divided by 4 is negative 4. Now what we notice here is we have two terms. This is being multiplied by C minus 4, and this is being multiplied by C minus 4. So for these two terms, this term and this term, we can factor that C minus 4 out of both of those. So when you have CD times C minus 4, what do you have left? We just have the CD. If I have 4 times C minus 4 and I factor C minus 4 out, that just leaves a plus 4. So that is the factors of this. C squared D minus 4CD plus 4C minus 16 is the same as C minus 4 times CD plus 4. We factored that out by grouping together and then factoring out just what is able to do that. And if you don't end up with the same thing, then either you've made a mistake or it's not factorable. It could be prime. Maybe there's no way to factor that at all. So, and you may have to rearrange it. If we had the CD over here and this 4C over here, we could switch places. We can move the minus 4CD next and add over here. It doesn't matter if you add first or subtract first when you do that. You can switch places if you need to. All right, let's find another example. Something good to do here. Let's see. Oh, this looks like a good one. I haven't worked this before, but we'll take a look at it. 30C to the third minus 20C squared minus 15C plus 10. Okay, well, the first thing we see is we do have a greatest common factor that we can pull out of there, right? Because we have a 30, a 20, a 15, and a 10, and those are all divisible by 5. They're not all divisible by 10 because of this one, or we could pull a 10 out, but we can pull out a 5. So once we divide 5 out of everything, this one does have a C, so there's nothing else we can pull out other than the 5. 6C to the third minus 4C squared minus 3C plus 2. Okay, so we've already factored a 5 out of it and gotten it down to this part right here. So now we want to use grouping, right? We'll group them again and see if we can factor anything out that way. So if we group these first two, so I've still got the 5. What can I pull out of 6C to the third minus 4C squared? Well, they both have a 2, and they both have a c squared. And what's that leave? 6c to the third divided by 2c squared is 3c. And negative 4c squared divided by 2c squared is just negative 2. So that's what this factored out to. Now this one right here, we just have negative 3c plus 2. Well, with that negative out front, let's factor out a negative 1. And that makes it, if we factor negative 1, that becomes a positive 3c and a minus 2. And we've made these the same because we needed those to be the same. So now we still have the 5 out front. We can factor out that 3c minus 2 is the first term because it's in both of these terms. See, it's right there and right there. So what's left over now is you have this 2c squared minus 1 as your other term. 2c squared minus 1. And we factored this down to this, and that is about as far as you can get it. Can't factor that any farther. This is not perfect squares, not the difference of perfect squares, because 2c squared is not a perfect square. If this was just c squared minus 1, that's the same as c plus 1, c minus 1, because that'd be the difference of squares. But the 2 in front of it is not a square. So that kind of knocks that out. All right, let me see if we have one last example to be able to do this. And really, this just takes a lot of practice, guys. Factoring is a practiced skill. So the more you do, this lesson has a lot of practice problems. So make sure you're doing that. So, okay, factor, greatest common factor, binomial. Okay, there's the lesson summary. Oh, let's try one like this just to check it out. 2s squared. Let's make it x. 2x squared. X is easy. Easy to see. 2x squared minus x plus 3. Oh, it's a little different. We don't have just an x squared. We have a 2x squared. So when we're trying to find factoring numbers, we have to consider the 2 times the 3. You got to take the coefficient of the x squared times this to, to figure out what the numbers are. So we're looking at all the factors of 6, 2 times 3. So the factors of 6 are negative 1 times negative 6, negative 2 times negative 3, 1 times 6, and 2 times 3. Right? And which of those, if we did that, would add up to be negative 1? Because that's our middle term, negative 1. So if we add these together, that's negative 7. If we add these together, that's negative 5. If we add these together, it's a positive 7. And that's a positive 5. None of these will add up to the negative 1 that we need in the middle. So that means this is prime, and there are no factors of that. This cannot be factored. It's a prime number. It's a prime polynomial. It's as small as it gets. So if we can't find a number that we could break this apart and add up to that, then this is a prime number. So I wanted to do one of those just to show you what happens when you can't factor, because not all polynomials are factorable. Some of them are as small as they get, already down to the smallest factor. So, boy, there's a lot of examples in these 2 lessons. A lot of it. You need a pencil and paper. You need to be trying what it has. Like, it's got factor completely, and it'll give you this, and it'll tell you the steps. Factor out the greatest common factor, but it won't show it to you. So you can try to do that. Okay, let me factor out the greatest common factor. After you do it, you can click on it, and then they'll open up and show you, oh, here were the great common factors. Is that what you got? You're like, oh, good. And then it tells you split the middle term. All right, so you're trying that. Then open it up and see, is that what you got? It's got a lot of that to where it will walk you through the examples. So in the lessons, take the time to go through those examples, and that way you'll have it down. So when you get to the quizzes and the tests and all of that good stuff, you're like, hey, that's no problem. The other great thing about doing all of these examples, like all these examples that I have written down here, is when the test comes or the quiz comes and I look at that problem, it's like, oh, I did one like that. Where's that at? I'm going to pull out my notes because I can use my notes on every test and quiz in here. I've gotten all these examples right here, and I can have an exact problem that is just like on the test. Now, that's a different equation on the test, but I'm doing the same thing I did on this notes. So I know what to do. Okay, first I factored that out. All right, so I need to factor that out on the test. Okay, then I was looking for this. All right, I'll look for that on the test. Use these notes. Use them to help you do it. Of course, if you're not taking notes, it's hard to use them. And you have to remember, oh, what was that? Where did I find that? You can use all of the, so do the problems in the lesson. It helps you understand it when you write it down, when you work through it, you learn it. You learn math by doing, not just by reading. Oh, let me look at the lesson. All right, I spent 8 minutes looking at the lesson. Well, you probably didn't get much. If you spent 30 minutes doing the examples in the lesson, you've probably got it down. When that test comes, you're killing it. Hey, look at that. I got a 94 on the test. Let's move on. I want you to understand this. I want you to, the test to be easy. And the only way the test is easy is if you've practiced enough to make it easy. All right, there's the bell. That's not our bell. That's just a bell for, again, some lunch period. But that's it. That's all I'm showing you guys today. That is a lot to chew on. Go through these lessons, do the 2 assignments, and then take the rest of the week off, right? We're not meeting again after tomorrow's meets, or the last meets for the week. This is the only meet for us this week. So have a great week. I'll hang around if anyone's got questions, but otherwise, we'll see you next week.
Let's get out of here. Word to your multiples. Math, baby.